Welcome to the General Chemistry 2 class. This section is on acid-base equilibria and salt equilibria. This section is about the effect of pH on solubility. Let's begin. In this lesson, we will explain the effect of pH on the solubility of a precipitate. Consider a saturated solution of calcium hydroxide. The solubility equilibrium is given by the following equation. Dissolving it in a sodium hydroxide solution shifts the equilibrium to the left, thereby lowering its solubility. The decrease in solubility is due to the common ion effect, which was discussed in the previous lesson. When calcium hydroxide is dissolved in an acidic solution like hydrochloric acid, hydrogen ion from hydrochloric acid acid consumes the hydroxide ion released by calcium hydroxide. Since hydroxide ion is removed in this process, the equilibrium position shifts to the right, that is, towards the dissociation of calcium hydroxide into ions. With this, calcium hydroxide is more soluble in acidic solutions than in pure water. The pH of a solution plays a role in altering the solubility of compounds which produce basic ions. For instance, lithium carbonate contains carbonate ion which accepts hydrogen ion to produce bicarbonate ion. Thus, an aqueous solution of lithium carbonate is basic. When mixed in acidic solution, carbonate ion from lithium carbonate is consumed by hydrogen ion, causing the equilibrium to shift towards the direction that dissociates lithium carbonate. Thus, the solubility of lithium carbonate is increased. As for the case of lead chloride, the anion chloride ion is the conjugate base of hydrochloric acid, which is strong acid. When the acid is strong, its conjugate base is too weak that it cannot act as a base in water. With this, hydrogen ion is not accepted by chloride ion, so no shift in the position of the solubility equilibrium is observed. Thus, lowering the pH does not increase the solubility of lead chloride. The table on the left lists down the strong acids and their conjugate bases, which are very weak. Thus, these anions are neutral in water. The other strong acid, sulfuric acid, has a conjugate base bisulfate which produces hydrogen ion in water, thus acidic. Because of their very weakly basic nature, metal ion salts of these anions, like lead iodide, do not increase in solubility when the pH of the solution is lowered. Anions not listed here are generally basic in water. Thus, metal ion salts of those anions tend to become more soluble at low pH. Some examples of basic anions are on the second column of the given table. There are conjugate bases of weak acids. Metal ion salts of these anions, like sodium fluoride, tend to become more soluble at low pH. To summarize, the solubility of compounds that produce basic ions in water can be increased by lowering the pH of the solution. So this is the references, and that would be all. Thank you.
Acid-base equilibria and salt equilibria. Part 12. Effect of pH on solubility. Quiz. Multiple choice. Determine whether the solubility for the following compound increase in acidic solution. Number 1. MgF2. A increases. B does not increase. Number 2. RbClO4 increases. B does not increase. K2SO4 A increases. B does not increase. AgBr increases, does not increase. FeOH3 increases, does not increase. AlPO4 A increases, B does not increase. CD3PO4 2 A basic, B neutral. Ag2C2O4 A basic, B neutral. CdCO3 A basic, B neutral. TLBr A basic, B neutral.